Last but not least, we have the HPC Innovation Awards. So first I'll give a little information about the awards itself. Here's some examples of the previous winners and also the trophy that the winners will be receiving shortly after this presentation. First, the award program goals. So the first goal is to help expand the use of HPC by showing real examples of the return on investment and to show these HPC success stories. Second is to create a large database of success stories across many different industries, verticals, and disciplines in order to help justify HPC investments and show non-users ideas of how they could incorporate HPC. It's also giving funding bodies and politicians a better understanding of the value of HPC and a chance for OEMs to demonstrate success stories with their products. So users do submit the value of their accomplishment on 3 specific areas. First is the dollar value. So for example, the revenues or cost savings. Second is the scientific or engineering accomplishment. So for example, discovering something new. And third is the value to society as a whole. So for example, if they made something safer, that intrinsic value. And then we also collect the investment in HPC that was required. Then there's the judgment process, which is done by HPC users. First, we look at the completion of the submission and make sure that there's a clear value shown. Next, the HPC User Forum Steering Committee evaluates how realistic the value and returns is that was reported. And then in cases where the value isn't clear, or maybe there's more technical required, the final evaluation is done by experts in that specific area. Okay, without any further ado, this is this year's Innovation Award winners in no particular order. First, we have Andre Lyland from Hokkaido University. This research was related to energy and discovering materials that can be used for energy more efficiently. They developed also some novel computational methods that can be used to discover further materials in the future for energy and environmental applications. Next, we have Jean-Philippe Piquemal from Sorbonne University and Qubit Pharmaceuticals. This was related to COVID-19 research. They synthesized new compounds and produced a high-resolution molecular dynamics simulation of the COVID protein, identified drug sites and drug candidates, and opened routes for further drug discovery and design. Next, we have Rolf Schneider from the High Performance Computing Center at Stuttgart. This was predicting the ICU occupancy in Germany due to COVID-19, and this was produced weekly for the Germany government in order to provide actionable information for them to make decisions in this critical situation. Next, we have Francisco Ramirez Havega from Better. This was related to air pollution, which is a problem in Europe due to the health risk. However, they do note that urban air quality problems are usually related to local problems like land use and traffic. And so the simulations that are required to come up with answers can be cost prohibitive. So what they did was they ran CFD simulations of wind flow and dispersion patterns and trained a deep neural network to simulate the results at a fraction of the time and cost. And they make this available to local governments in order to provide information about their local emissions. And finally, we have Todd Simons from Rolls-Royce. This was relating to a model of a gas turbine engine. And specifically, they worked with the developers of LS-DYNA to improve that program so that it would run on scale and that it would reduce the time to solution very significantly. And this will positively impact other sorts of designs in the future as well. Congratulations to all the winners, and thank you for listening. You can contact us here.